After discussing the three equations of motion, we will discuss how to use that three equations to solve numerical. तो अभी हम डिस्कस करेंगे the three equations of motion. For that, you will have to understand one situation. It is supposed that a body starts its journey at position A. पोजीशन ए में जब बॉडी का जर्नी स्टार्ट हुआ था तो उसका इनिशियल वेलोसिटी इज कंसीडर्ड टू बी u. So what is the initial velocity of the body that starts its journey? Initial velocity is supposed to be u, and the body moves under uniform acceleration. Let it be a. After some time, the body reaches position B. Let the velocity becomes v. So what is the initial velocity u? What is the final velocity v? What is the acceleration? Uniform acceleration a, and the time taken t. Let s be the distance covered. So this is a perfect situation where we can apply the three equations of motion. Here a body is moving under uniform acceleration. इसका मतलब body का speed, velocity keeps on increasing. And the three equations of motion are: first one, v equals to u plus at. Second one, s equals to ut plus half at square. And the third one, v square minus u square equals to 2as. And you should write down the meaning of that symbols given here. U represents initial velocity, starting velocity. V represents final velocity. T represents time taken. A represents uniform acceleration. But the three equations can also be applied for a body moving under uniform retardation. And minus a represents uniform retardation. S represents distance covered or displacement of the body. Distance covered by the body or displacement of the body. So the three equations of motion, you should note down the three equations of motion. First one, v equals to u plus at. Second one, s equals to ut plus half at square. And the third one, v square minus u square equals to 2as. Under what condition these three equations can be applied? If the body moves under uniform acceleration or uniform retardation. One more thing you should know here is that we know one formula of average velocity. The formula of average velocity is total displacement by total time taken. The formula for average velocity is total displacement by total time taken. If the body moves under uniform acceleration or retardation, then we can also apply another formula for average velocity. The formula for average velocity in the situation if the body moves under uniform acceleration or retardation, we can write average velocity equals to u plus v by 2. So this is important formula. So I discussed mainly four important formula here, three equations of motion and one formula for average velocity. The three equations: first one, v equals to u plus at. Second one, s equals to ut plus half at square. Third one, v square minus u square equals to 2as. And average velocity formula u plus v by 2. So in the next part I will discuss how to prove these formula using different other formula. Okay, the three equations. Now we are going to establish the first equation of motion, and the first equation of motion is v equals to u plus at. इसको प्रूव करने के लिए we have to consider one situation. So we are considering a body starts its journey with initial velocity u. So we can write, let a body starts with initial velocity u and it moves under uniform acceleration a for time t. So the initial velocity is u and the body moves under uniform acceleration a for time t. So body started from a, initial velocity u, the body moved for time t under uniform acceleration a, let the body reaches position b and the velocity becomes v. So we can write here, let the final velocity of the body be v. So इस सिचुएशन में इनिशियल वेलोसिटी है u, फाइनल वेलोसिटी क्या है, इट इज v, टाइम टेकन इज t and the body moves under uniform acceleration a. And we know the definition of acceleration. By definition we can write acceleration a or uniform acceleration a is equals to change in velocity by time taken. Change in velocity by time taken. So change in velocity is, we can write here, final velocity minus initial velocity. This is change in velocity and time by time taken. So acceleration is change in velocity by time taken. So we can write final velocity minus initial velocity by time taken. So a is equals to v minus u by t. We can write, because symbol for final velocity is v, symbol for initial velocity is u, time taken t. So if we simplify, we'll get at is equals to v minus u. So at plus u is equals to v, or we can write v equals to u plus at. So the equation is v equals to u plus at. This equation is established. Okay. So in this way we can prove the first equation, we can establish the first equation of motion, where the body started with initial velocity u, final velocity v, acceleration a, time taken t, and so the equation is v equals to u plus at. So in this part we are going to establish another equation of motion, and that equation is s equals to ut plus half at square. To prove that equation we have to first consider one situation. Let us try to understand that situation. So it is supposed that a body starts its journey from position A, its velocity is u. एक बॉडी का जर्नी स्टार्ट होता है पोजीशन A से और उसका इनिशियल वेलोसिटी है u. This body moves under uniform acceleration A. बॉडी का acceleration A and it reaches position B and velocity becomes v. तो हम लोग u को इनिशियल वेलोसिटी बोलेंगे, v को फाइनल वेलोसिटी और a is uniform acceleration. Let the time taken be t and the distance covered or the displacement be s. So first you have to note down the starting statement, and the statement is, let a body starts to move with initial velocity u and it moves under uniform acceleration a. So body moves with initial velocity u, body is moving under uniform acceleration a for time t. Let the distance covered be s. And we know what? We know the formula for average velocity. Formula for average velocity for a body moving under uniform acceleration, I already told you, we can use the formula u plus v by 2. So average velocity equals to u plus v by 2. Let this be relation 1. Again, we know the formula, distance covered is equals to velocity into time. Since the velocity is not constant, the body is moving under acceleration. Here distance covered we can write is equals to average velocity into time. So we got the relation distance covered is equals to average velocity into time. यहाँ हम लोगों ने average velocity ये क्यों लिया यहाँ पे? क्योंकि body uniform velocity में नहीं है. In that case, distance equals to velocity into time इस formula में velocity कौन सा लेना होगा हम लोग को? Average velocity. So distance covered is equals to average velocity into time. So we can write s equals to, for average velocity we can write u plus v by 2 into t. So now s equals to u or v equals to u plus at. Already हम लोगों को पता है, we have already established the equation 1 where v is equals to u plus at. यहाँ मैंने v के जगह पे u plus at क्यों लिखा है? क्योंकि look at this equation, यहाँ v का कोई requirement नहीं है. So s equals to u plus at by 2 into t we can write. Now in the next part, s equals to u plus u, we can write 2u plus at by 2 into t. Okay, so 2u plus at by 2 into t. So s equals to, now if you multiply this t with 2u and at, we'll get 2ut plus at square by 2. So after multiplying this t with 2u and at, you will get 2ut plus at square by 2. So s equals to, we can write 2ut by 2 plus at square by 2. Okay, so s equals to 2ut by 2 plus at square by 2. So it becomes s equals to, therefore we can write the final equation is s equals to ut plus half at square. So you can note down the starting statement here. Let a body starts to move with initial velocity u. Let a body starts to move with initial velocity u and it moves under uniform acceleration a. Uniform acceleration a. Let the body covers a distance s and the final velocity of the body becomes v. So what is the initial velocity u, what is the final velocity v, displacement or distance covered, s, uniform acceleration a. And we know one thing, we know the formula for average velocity. Formula for average velocity is already known to us, u plus v by 2. Let this be relation 1. Again, we know that distance covered or displacement is equals to average velocity into time taken. We have already discussed while proving the equation 2 that s equals to average velocity into time. This relation can be written. So s equals to average velocity into time. S equals to, for average velocity from equation 1 we can write u plus v by 2. So it is u plus v by 2 and the time is t. So s equals to u plus v by 2 into t. So s is equals to, we can write v plus u by 2 into t. So we can easily write u plus v, instead of u plus v I am writing v plus u. So s equals to v plus u by 2 into, for t we can write from equation, we know that a is equals to v minus u by t. So t is equals to v minus u by a. From this relation we can write, instead of this t we can write v minus u by a. From this formula of acceleration, a equals to v minus u by t, so t equals to v minus u by a. So instead of t we are writing v minus u by a, and look at this equation, t is not required. So instead of t we are writing v minus u by a. So s is equals to v plus u, v minus u by 2a we can write. So s is equals to, we know the formula, a plus b into a minus b, it will be a square minus b square. So here we can write v square minus u square by 2a. So we can write this 2a multiplied by this s, 2a s is equals to v square minus u square. Therefore we can write v square minus u square is equals to 2as. Now the equation is proved. The final equation, v square minus u square equals to 2as. After discussing the three equations of motion, now in this part I will discuss how to solve numericals. Today I will discuss only three numericals. Three numericals I will solve for you, and 3 will be given to you for your self-practice. In the last part of the video, a challenge question will be given. If you can answer that challenge question, and if you can send your answer to the WhatsApp number given in the description, your name may be announced in the next video of the same topic. But for that, you will have to among the top 5 senders, early 5 senders by 2 p.m. 1st of April 2020. You can send your answer by 1st of April 2 p.m. 2020. You should be among the top early 5 senders of the answers of this particular question to the WhatsApp number by 2 p.m. 1st of April 2020. Any entry, any answer sent after 2 p.m. 1st of April 2020 will not be accepted, and that answer will be disqualified for this challenge. Now the question number 1 for this part. Question number 1, a bus moving along a straight path at 20 meter per second undergoes an acceleration of 4 meter per second square. Calculate the velocity of the bus after 2 seconds. तो इस न्यूमेरिकल में अगर हम लोग सिचुएशन डिस्कस करें तो ये बॉडी का स्टार्टिंग वेलोसिटी है 20, बॉडी का एक्सेलरेशन है 4 मीटर पर सेकेंड स्क्वायर, टाइम टेकन बाय द बस इज 2 seconds. You will have to find out the velocity. So what are the given things? First you note it down. U is given, initial velocity 20 meter per second. Then acceleration is given 4 meter per second square. Time taken is given 2 seconds. You are asked to calculate final velocity. So आपको U, A और T given है, you have to find out V. और just we have discussed the 3 equations. Out of that 3 equation, कौन सा equation यहाँ fit बैठता है वो आपको सोचना होगा. And that particular equation is V equals to U plus AT. You are given U and A and T, and you are asked to find out V. So you can write, we know V equals to U plus AT. U का वैल्यू यहाँ पे given है, it is 20 meter per second, plus acceleration, it is given here 4 meter per second square. Time is given here 2 seconds. So it is 20 meter per second plus 8 meter per second. यहाँ सेकेंड स्क्वायर, यहाँ सेकेंड, तो कैंसलेशन होने के बाद बचेगा 8 मीटर पर सेकेंड, 4 to 8. Now the answer is 28 meter per second. So the final velocity of the bus is 28 meter per second. Now we are going to discuss second question of this part. Question number 2, a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds if it starts from rest? Look at the solution here. The body starts from rest, इसलिए U होगा 0. Acceleration given है 4 meter per second square. Then time is also given 10 seconds. And you are asked to calculate the distance covered. The perfect equation to solve this particular numerical, you have to find out distance or displacement as equals to ut plus half at square. U का value is 0, time is 10 seconds. Then acceleration is 4 meter per second square, and time is 10 seconds, so it is 10 second whole square. So if you solve it, 0 into 10 will be 0, so we can write half into 4 meter per second square into 100 second square. So S equals to, if you do the cancellation here, 2, so 2 into 100 is 200, and the unit second square will be cancelled, so it will be meter left here. So SI unit of distance is meter. We got the answer, S equals to 200 meter. So the distance covered by this racing car is 200 meters. Now we are going to discuss question number 3, and you should note down first the question. Here given a car moving at a speed of 10 meter per second is stopped by applying brakes, which produce a uniform retardation of 0.5 meter per second square. How much is the distance covered before it stops? So if you look at the solution here, car was moving at this speed. So initial velocity or speed can be considered as 10 meter per second. Then brakes are applied and uniform retardation is produced. Retardation is negative of acceleration, so minus A is 0.5 meter per second square. Here we can write therefore A equals to minus 0.5 meter per second square. So now you are having initial velocity u 10 meter per second and retardation 0.5 meter per second square. Then how much is the distance covered before it stops? So final velocity 0 and you are asked to find out distance covered. How much is the distance covered before it stops? So finally the velocity becomes 0 and you are asked to calculate s. Here time is not given. You are given u, you are given v, you are given minus a or a. You are asked to find s. Now the equation to solve this, if you look at the given things, you can easily understand which equation you need to apply. It is v square minus u square equals to 2as. V square minus u square equals to 2as. So final velocity given here, it is 0, so we can write 0 square minus initial velocity, it is 10 meter per second, so 10 meter per second whole square. Then 2 into acceleration given here, it is minus 0.5 meter per second square, and you are asked to calculate distance covered. Now if you simplify it, 0 square is 0, so minus 10 square is 100, so we can write here minus 100 meter per second whole square, so it is meter square per second square. That is equals to 2 into 0.5 is 1, so we can write here minus 1 meter per second square into s. This minus sign can be cancelled. Now s is equals to 100 meter square per second square by 1 meter per second square. Therefore s is equals to 100 meter. So what is the distance covered by the car? The distance covered by the car is 100 meter. So we discussed 3 numericals where we have applied the 3 equations of motion. It's time for self-practice. You have to note down these 3 questions and try to solve these 3 questions using the equations of motion. Answers are given for your convenience. First you try to solve it and then compare your answers with the given answer. Now the challenge question. The question is, on a 120 kilometer track, a train travels first 30 kilometer with a uniform speed of 30 kilometer per hour. Calculate the speed with which the train should move the rest of the track so that the average speed of the entire trip becomes 60 kilometer per hour. You should try to solve this particular numerical. If you can find out the answer, you can take a pic of that answer. You can send that answer on the WhatsApp number given in the description. If you were among the first 5 senders, quick senders, then your name may be published in the next video of the same topic. Now it's time to announce the name of the winners of challenge question of chapter motion part 3. The answer is R root 2 and the winners are number 1 Mudit Golcha, number 2 Sanchit, number 3 Ravi Jain, number 4 Swati Deka, number 5 Yash Agarwala. Thank you.